Kirtana, within next 10 minutes, I'll be starting, okay? Yeah, hello, great. So, look, in the last class, we did some problem based on Faraday's law and the Lenz's law, right? So, today, mm, we can actually go ahead with some more problem variation, and then maybe we'll be going with one topic later on. All right, so so Kirtan, just take one problem. It's an infinite wire having some current I. At some distance, we have kept this rectangular loop. So assume this is to be the distance A, and after some distance, there's a rectangular loop of. Now, Kirna, what we are doing is we have this loop. Assume this is an axis of the loop. Okay, this is an axis, vertical axis. So basically, what we are doing here, we are rotating this loop with respect to this axis. Okay, we are going to rotate with some angular with omega. Okay, let's not go with this omega. I'm saying, yeah, this height assumed to be h. Okay, this loop is rotated by pi angle about the axis O. Okay, the axis O. So basically, this is an O axis. About this, we have rotated it with pi degree, basically from here to here, which should be pi. Okay, if I say this is an angle, so it has been rotated by pi degree. Understood? This is what we have done. So you need to find the total charge flown in the loop. How much charge must have passed in the loop? Okay, this is what you need to calculate. Okay, that's the problem over here, and I'll just give the full geometry. So this is L length. Also, all the angles are 90-degree by themselves. Yeah. So that's the problem, kid. Now you can try it once. So solve it once. And let me know the answer fast. Kirtana, you are trying the problem?
Sir, can you explain?
Uh, Kirtana, look, this problem is a similar problem which we have already done once. We have already done similar kind of problem earlier also. I think you may try it once. Look, Ajam, I'll leave that part. Kirtana, assume that when I'm saying you need to calculate charge, what thing you need to calculate first?
Current.
Current, right? So how can you calculate current in this situation? What's the key concept over here? I think you should be able to calculate now because we have done many problems based on the same things. We have seen many situations where we had this kind of current, we have this kind of loop, we were flipping it from here to here. Could you remember that? We already did this multiple times, right? Same loop. We calculated magnetic field passing out through the loop, which we did it by integrating the whole thing from here to here. What was the magnetic loop phase we got? Something B directly proportional to log of A plus L2 divided by A. Something this was the case, right? Some constant factor was there here. Basically, some portion was also there. So we are taking this from here to here. You should be, you should remember all those things. All right, I don't know. Okay, look, if you go and calculate the current, look, what is the how you are going to calculate current? I don't know. Current is basically charge, like, sorry, charge dt, right? This is what the current is all about. Okay. What I can simply do is I can instead calculate how much current is passing out through this. Okay, in the whole time of access. This is what I can focus and calculate. So how I can do this? I know, I know one thing. When this loop is passing through this, assume there will be like at the current situation, current is like this, magnetic field will like this. Due to this current I, bigger current I, there will be magnetic field like this. Okay. So at the current situation, the situation is like this. But when you are rotating it from here to here, this loop must be in some situation like this. Okay, where the magnetic field is still going inside, but the angle between them, because this right now this loop is at some angle this, okay, magnetic field going inside, or you can actually say, sir, magnetic field going in this way. Okay, the magnetic field is going this way, area vector is this way, so add some angle theta, because earlier this angle was 0 degree, like this. It is going from 0 to completely one, what I can say, the pi degree, okay, completely making pi degree to it. So during going from 0 to pi degree, it must be making some angle theta randomly, right? So what you can say is, we need to integrate that thing. How we can integrate that thing? It's a very simple idea. We already know. What we can do is to calculate this, we can simply calculate EMF. What is EMF? Change in flux. Okay, next. What is the change in flux? Net change in flux. You know, we are talking about change in flux, right? It does not depend upon path. So I can calculate final minus initial and whatever the time I spent, right? If I get to know this thing, it will be much better for me, right? Understood? So what is the flux change we are going through? You already know that flux change is nothing but whatever the area is there. If I multiply that with the what I can say magnetic field, I'm going to get it right. What is the magnetic field? You know, in this situation, if you integrate each of the portion, the magnetic field you are going to get is mu naught I height h, right, divided by 2 pi log of a plus L divided by a. Now, if you ask yourself from how we, okay, do you know how to calculate this statement? Could you remember how we can calculate this thing? Kirtana, can you calculate how, like, can you let me know, like, how we can calculate this thing? This magnetic field B, which is mu naught I h divided by 2 pi a plus L divided by a. I wanted to calculate this thing.
Yes, sir.
Okay, makes sense. So this is for this side. What will be the magnetic field for with the loop which is flipped by pi degree? If this loop is here after some time, so what will be the magnitude from this part? This is before. Okay, let's call it as 0 degree. This is at d pi degree. Right? So what will be the magnetic field from this part here now?
Listen,
How much?
same.
No, it won't be the same. If it's same, so how it is going to be the same? There will be at least some difference. What's the main difference about that thing? I'm asking.
Negative.
Yeah, that will be negative. That's the main thing, right? So it will be negative. Okay, no, it won't also be the same. Also, the this length and distance will be different, right? Here, this A will be basically A plus L. Okay, and the total will be A plus 2L. So this will be more thick, okay? So it will be going from A plus 2L divided by A plus L. Understood? What we are doing is total length divided by starting point. Starting point is this, final point is this. In this, for this loop, the starting point is A plus L, total point is A plus 2L. No, 2A plus L actually. 2A plus, sorry, 2A plus L by A plus L. That's the thing. Mm, is it? No. It is A plus 2L. This is this L 2L, right? So A plus L, A plus 2L. That's what the magnetic field is about. So what is the flux? Okay. What is charge? Charge is nothing but I, sorry, mm, charge is nothing but I dt. Okay, makes sense. What is current? EMF by R times of dt. Okay, what is this current? What is this EMF? That is nothing but d phi by dt times of R. So what is dt? No, that is multiplied with this dt, right? So I don't know about everything, but I know about the change in flux. So change in flux I know. So I can simply go and put this got cancelled. So what is the charge you got? That is change in flux divided by R. Flux divided by R. So just put the answer, get the thing. Charge is nothing but 1 by R. And what is the change in flux initial final? So you can either engage with whatever you want it, right? Simply make it like mu naught I H, that is constant. The one is negative, one is positive. So when you subtract it, it will become addition. Okay, divided by 2 pi as it is. Yes, 2 pi is there. So you know what you are left with. Sorry, it was in log form. There was a log over here. Okay? Here there should be a log. I forgot to like the log part. A plus L by A plus 2L by A plus L. Okay? Now you know if you subtract the log part from here to there, what will happen? A plus L by A log minus, it will become plus basically log of A plus this by this, right? So you know addition is basically multiplication. So remove it, multiply that A plus 2L by A plus L. A plus L got cancelled. What you will get? A plus 2L divided by A. So here, what will be the final answer? A plus 2L divided by B. That will be the thing. Okay? I hope this is clear for you. Okay. Now we can try to move to the next problem also. Yes. Okay. So look, whatever we are solving in this chapter or something, always keep remember that E is equals to negative d phi by dt. Okay. This formula is helpful in every place. This negative just suggesting you that this flux induced or change is basically this EMF induced is going to oppose the change in this thing. Okay, that is the role of this negative part, nothing else. Okay, so mm, all right, now so in this thing, what we can do is all right. Good. Now let's do one problem. Quite lengthy problem we are going to do now. So you are given a magnetic loop like this. No, this is base same condition. Okay. There's a current I. I don't know what's the value for this one, but we'll be doing some parts of it, not just one part. Again, add some distance A. Loop is like A plus L plus H. Okay. So the first part is as always what I okay. This is your thing, right? This will be your loop. So first part is find magnetic flux. So Kirtana, we already know this thing, right? Can you tell me the value of magnetic flux in this case, passing through the loop? Kirtana, can you tell me the magnetic flux passing through the loop in this case?
Sir, is it you not I H by 2 point log A plus L by A?
It's the thing itself, right? Okay, we take the h divided by 2 pi. Okay, that's fine. But that, okay, we already know this thing, that's why it was not even part of our problem. The problem starts from this one, okay? So the part is, assume if the current is nothing but is growing current, basically this current is not a constant, instead it's a growing one. So I is equals to I naught e to the power minus t to the by tau. This is the current, okay? It's a growing current. Then find the EMF induced in circular loop. EMF in circular loop. That's what you need to calculate. What's the EMF you are going to have? Okay, that's what you need to calculate. So can you calculate the EMF in the loop? Krishna, do you know how to solve this?
Yes.
Solve it once and let me know the answer first.
That is that u naught h by 2 pi into log a plus I divided by a into I minus I naught e to the power minus t by t.
Wait. You are telling the value of EMF, right? You are giving me the value of EMF or flux?
It's like
It's flux. Wait. I want EMF. What will be the EMF?
Sir, is it u naught h by 2 pi into dt into log a plus L divided by a into I minus I naught e to the power minus t by tau?
Yeah, it's similar to that thing. Alright, so EMF, which basically we're going to get is, alright, before that, what is the current? We already know the magnetic field from this will be nothing but, the current is there, right? Instead, right now, my current is varying, so you can just put the value of current over here. What is this? This much. So what is the flux from this you are going to get? That will be nothing but area, which is a L into H multiplied by whole thing. So mu naught I, instead of I, keep it as I naught E minus T by tau, and that will result you around, okay, L into H, that will be L H square, rest is 2 pi, right? A plus L, the whole thing divided by A. This is what you are going to get. So what is the EMF? Minus d phi by dt. So when you differentiate it, if you see all this part is constant, just this part is dependent upon time. So the constant will be as it is. This thing is going to get differentiated, but one thing is clear that the differentiation from exponent is that itself, so that will be minus t by tau. Differentiating this part will result in there was a negative in the front, so this negative will cancel out by this negative, and this tau will go down. So this is what the EMF you are going to get. Understood? Now you can see your EMF is varying with the time, basically increasing with the time, right? As your time is increasing, your flux is increasing. Basically, EMF is increasing. Also, you can simply put the, if you want your current, so current will be but E by R. This R is given only. So that's okay. So mu naught I naught initial current L H square divided by 2 pi tau times of R A plus L by A. E minus T delta. Now, what will be the direction of current? So you can see current is increasing with the time or decreasing with the time. Mm, it is actually decreasing with the time, not increasing with it. So because it's in decreasing with the time, so your magnetic field should be generated in a way that it could support them. It could just support your current. So what will the answer be like this? If magnetic field is in this way, it is going to support your current. So EMF should be generated from this one, right? That is going to be the answer. Clear? This is the second part. Alright, so this is fine. Yeah, Kirtan, any doubt?
No, sir.
No doubt, right? This is mm, alright, Kirtan, look, let's talk about another problem based on a solenoid. Okay, so if you could remember, we have already studied about solenoid, right? So here I am having a solenoid. Here I have a solenoid. Okay, Yes, okay, this is basically solenoid. This time, what I kept is this is an axis of the solenoid. Okay, this is nothing but an axis of the solenoid. Along this axis, I have kept a loop, a circular loop at some angle theta. Okay, this is some other loop, circular loop. It has some area 1. This solenoid has some area 1 and this has the area 2. Okay, this is the thing you are having. Okay, also the number of turns n is number of turns per unit length. So first thing which you need to calculate is find out flux through a small loop. You have given this small loop. What is the flux passing out through this one? Okay, that is what you need to calculate first. So assume the current is I. Yeah, basically current mm, current is going from I value to 0 in this solenoid in time t. Okay, so what you need to calculate is you need to calculate average EMF. So before that you just calculate the flux and then we'll move to the next part. This is first part. This is second part. If current is going from 0 by I to 0 in time t, find E average. Either you're solving it or not.
Solving.
It's not even that hard to get the answer. This problem is a bit easy itself. If you're not be taking much time on it. Which part you are solving now? First part or second part?
First one.
Just figuring out the flux from a smaller loop. Is it that hard? It's been already 3 to 4 minutes, right? You're supposed to solve the complete problem in this time. And you are yet stuck on the first step, calculation of the flux from a smaller loop.
Sir, is it the U not I into
You not tie into
N?
something else, just this thing. There should be some more factor. Look, what is the magnetic field through the solenoid?
not I by cos alpha plus cos theta.
Now wait, just tell me what will be the magnetic flux, magnetic field through the solenoid. Mu naught N I on that formula. Mu naught N I, number of turns multiplied by current. Okay. Current is going from I to 0, that is fine. We'll look at this later on. But fine, right now what is the flux? Mu naught, basically B dot A. This is area. It is at some angle theta with magnetic flux. B. That will result B A cos theta. What's the answer? B A cos theta. Mu naught and I. What is area? A2 cos theta. Okay. That's what the answer is. I'm asking what is the current? Okay, E current is going from I to 0. What does that mean? This current is changing from I to 0. Here you need to calculate E average. What is the E average? That is change in flux divided by time. Change in time, right? So you can simply say, so what's the current over here? The current is coming out to be initial flux. When current is there, it has some value. So mu naught uh, N I A2 divided by cos theta. This is the initial flux minus final flux. Current is 0. That is 0. So that will result you the average EMF. That's the answer. Only answer. Okay, this is the thing. What if instead of this, your current is something like this? Current is, instead of going from 0, it is dependent upon some value I naught sine of omega t. Then what you are going to do in that case? It will be very simple. Simply differentiate it, okay? Because in that case, because it is changing at every moment, it's better to go and take a differentiation. So here you will be differentiating I part, so it will be coming out as di by dt. So in that case, this mu naught and a2 cos theta by time. What is this omega t? Sine of omega t. If you differentiate I naught sine omega t, that will result you around I naught cos omega t divided by omega. So it will be like cos. Sorry, it will become cos omega t divided by omega, and I naught will be sum in between. So that would be the answer in that case. Clear? These two things are there. So let me know if you are clear with the thing. It's the same thing which you are doing from a very long time. Okay. Now let's do another problem. Look, whatever we have done, all these problems are very simple. Okay, just a very formula basic. All these are formula based problems. Okay. So now, the last problem for today's lecture. A bigger circular loop. From this axis, there is another circular loop. Okay, kind of this. This circular loop has some velocity v towards this side, has some number of turns n, and radius is r. About this circular loop, it has radius r, it has number of turns n1, and yes, there's a constant current I. Here the current is constant I. What you need to fix? Initial value, initial uh, distance is x. Okay. One more thing is also given that this r is very, very, very less than x. Okay. So you need to calculate, find the magnetic, you need to calculate magnetic flux. You just give me this value, I'll discuss about the EMF part. Kirtna, did you even calculated that thing?
Yes, sir. Is it u naught I x by 4 pi to into n1 minus n2 divided by r square minus small r square into t?
Yeah, that's the similar thing. Okay, what we can do is I'll give the answer now. So look, one thing. Due to this magnetic field, due to this bigger loop, at this point, what is the magnetic field in this direction? Look, magnetic field will vary in this direction, I will in this direction. Okay, so we don't even have to bother about the direction too much. So what is going to be the magnetic field? Mu naught I, number of loops is n1. What is the next part? The bigger loop r square divided by 2 pi, no, not 2 pi, um, r square plus x square. I think this was the formula for this one, right? 3 by 2. Could you remember this thing?
Yes.
Okay. So if you could remember this formula has small mistake, what's that mistake? It should not be 2 pi, it should only be 2. Okay. So this is the main thing. Now, if you see carefully, this is area of a loop, right? Like we can take whatever we want. For example, if the current is in right now this direction, so we'll say this is the area right now. If current is in this side, we can say area is this. Although this is the direction we are going in, it's better to take it this as area. So assume if this is an area vector, so what is the flux? That will be nothing but mu naught I n1 r square divided by 2 r square plus x square 3 by 2. Okay, makes sense. Multiplied by pi r square. Okay, pi small r square. This is what you are going to get. I hope this makes sense. Now we need to calculate what. Okay, one more thing. This area will be because there's n2 loops, right? So area will be multiplied by n2. The total area will be n2. That is one thing. Also, you need to calculate what EMF, right? So if I ask you to calculate EMF, that is the main twist. If you see carefully, is this magnetic field when this thing is varying, will it be same? I'll say no. Why? If you see this distance x is going to change. How it is going to change? Um, let's do one thing. Let's write this x in the form of v. What is that? Velocity. What is the velocity? The velocity is nothing but okay. There is no acceleration. It's just a time. So you can simply say, sir, initially the distance of x, but what will be the distance at some time t? I don't know. I don't know what is the distance. So how we can write this value x? We know that velocity is nothing but dx by dt, right? So do one thing, because velocity is constant, let's integrate it. So when you do this, initial is x minus, okay, you are going from some x to some position x dash. So x dash minus x is equals to vt. So what is x dash comes out? X plus vt. Understood? This is what you are going to get. What does this mean? When time is zero, your position is x. When your time has some value, your this x is going to decrease it. Okay, that is what we are going to get. Also, your velocity is because the position distance which you take in this direction, this velocity is in opposite direction, so it should ideally be opposite. So this will come out as negative. So this is what position comes out. Is that clear, Kirtana?
Yes.
So this is one thing. I'll remove it once because we have to differentiate in other format. Now, if you see carefully, what we can simply do over here is EMF. What is EMF? Differentiation of all the thing. If you see carefully, instead of I will take this part, rest of the thing I'll make some constant. So assume that constant k is mu naught I n1 n2 pi r square small r square divided by 2. This is my k. So the EMF is basically k, and by differentiation of 1 by r square plus x square 3 by 2. That's what the thing comes out. Okay? Divided by dt. So further on, if you write it, it will be like k differentiation of r square plus x square minus 3 by 2 divided by dt. That's what it is. So can we do this differentiation? So what will be the differentiation of the whole thing? That will come out as k. We are doing differentiation, so power will come outside minus 3 by 2 r square plus x square will be as it is, and the power is there. So when you do that thing, minus 5 by 2, I think so it should come out. What about the internal part? That will be r square differentiation is 0. For this thing, you are going to get 2x. Clear? That is what you are supposed to get. Is it completed? No. What about the x? You have just differentiated dx, so that will come out this. But what about dx by dt? That you also have to keep right. If you see carefully, this was negative, this is negative. Your dx by dt is basically decreasing by the time. So you can simply say EMF comes out as, and this dx by dt can be kept as minus v. Why negative v? Because your the x is in this direction, velocity is in this direction. Okay. So increase in one will decrease in another. So this k will come out as um, okay, it will be like minus 3 by 2 k r square plus x square minus 5 by 2 2x minus 3. Now just put all the values. So if you go and keep all the values, let's do one thing. Minus minus plus, so 3 by 2. Instead of k, let's put the rest of the thing. Mu naught I n1 n2 pi r2 square. This is r2 divided by maybe 2, so this becomes 4 due to that 2 also. Let's keep it as r square plus x square minus y by 2 2x v. That is the answer you are going to get. Okay. It's better if you can remove it from here and keep it at the bottom. So at bottom it will look like r square plus x square 5 by 2. Okay. And this will become 2. So that is going to be the answer now. Any doubt?
No.
No. Right. So Kirtan, that's all for today's session. Goodbye. I'll be ending this session, guys.